Welcome to Year 10 Physics, looking at describing motion. Okay, our learning intentions for this video are to appreciate that the motion of an object can be described in terms of position, speed and acceleration, to describe and explain the terms reaction time and reaction distance of a driver and the factors that affect them, to be able to describe and explain the factors affecting the braking distance of a vehicle, and finally to be able to use a graphic chart to determine the overall stopping distance of a vehicle at various initial speeds. So looking deeper into learning intention number 1, where we are going to look at motion of an object and look at these terms position, speed and acceleration. Okay, so what is motion? When someone says the word motion, what do you think of? So in terms of motion, as we've already said, we do have these 3 factors that play a part in how we can describe motion. Okay, so we've got this position, speed and acceleration, and we're going to look at each of these in a little more depth. Now when we think of position, we're thinking of the object moving from A to B. So it's that distance that the object has moved. And position is measured in a unit of distance. So for example, kilometers, meters, centimeters, millimeters. Okay, so it's that movement from A to B. So it could be driving from Melbourne to Canberra, from A to B. What is that distance? Now that next factor we've mentioned is speed. Okay, and this is the time taken for an object to move a distance. Okay, so in this respect, if we're talking our position being from Melbourne to Canberra, we would then be looking at the speed to get from Melbourne to Canberra. We'd be talking in kilometres per hour. For shorter distances or faster speeds, we might be talking metres per second. My Toyota Corolla will not be driving from Melbourne to Canberra in metres per second, okay, because it would be a very high value that we'd get. My Corolla doesn't go that fast to be able to have a usable number in metres per second. It's not an aeroplane. Okay, when we're thinking about speed, we will, in a video further on, start looking at the calculations to establish speed. Okay, but when you look at this, at the top there, the first formula, we've got speed equals time divided by distance. So we've talked about these things. We've talked about distance being that positioning, and then time, how long it takes. Okay, but once we know these things, so speed, distance, time, we can actually use we can use certain factors to find out different things. So if we're trying to find out the distance that an object's moved, well, if we know the speed and the time, we can work that out. If we want to know the time it's taken an object to get from A to B, if we know the distance and we know the speed it was moving at, then we can work out the time. So this is where we're heading to later in the unit. That third factor we mentioned was acceleration. Now, acceleration is whether our object is getting faster or slower over that set distance. And if you think of me and my Toyota Corolla driving from Melbourne to Canberra, obviously I don't go at set speed all the time. I may end up stuck behind someone going very slow on the road. There may be other times that all the conditions are good, I drive slightly slower. I might hit some roadworks and have to slow down. So speeding up and slowing down, that acceleration and deceleration along the journey. Okay, learning intention number 2 was to describe and explain the terms reaction time and reaction distance of a driver and the factors that could affect them. So when we think about this term reaction time, what it is every person takes a little time to react before events, and each one of us have very different reaction times, okay? Now, for example, there's a small delay before you apply your brakes when you're driving, okay, or when you're cycling, after you see the stoplight. So you're driving along or cycling along, you see the stoplight go red. There is a time between you seeing the stoplight go red and applying your brakes, which is called your reaction time. Now, whilst you've got that reaction time, you've got what we call this reaction distance, because whilst your brain is processing red light, need to stop, put foot on brake, there is a certain distance that's gone, and we call that the reaction distance. Now, there are factors that affect the reaction time and therefore affect the reaction distance. The longer it takes you to react, the longer the reaction distance will be. Okay, and those things include driver fatigue. So if you're tired, your reaction time will be longer. If you've been using alcohol, if you've drunk alcohol, if you've been using certain drugs, your reaction time will be longer. It takes you longer to process those signals and react to them. If you've taken caffeine, that can also affect your reaction time. And if you're not concentrating on the road, if you're looking at your phone, if you're distracted by the radio or something like that, obviously that reaction time will be increased, and therefore that reaction distance will be longer. Learning intention number 3, describe and explain factors that affect braking distance of a vehicle. So we've looked at the reaction time, okay, and that reaction distance, that is the time between you seeing the red light and applying your brakes. But once you apply your brakes, you've then got what we call the braking distance. So the braking distance is the distance the car travels once the brakes have been applied until it stops. So you put your foot on the brake, okay, and the car will continue moving for a moment before it stops. Now, this braking distance has a few different factors affecting the length of the braking distance. Now, there's several factors that will affect the braking distance of a vehicle. Okay, so rain and snow, wet roads, snowy roads, icy roads reduce friction between the tyres and the road. Therefore, when you apply your brakes, it takes a longer time for the vehicle to stop. It will literally skid along on the water or on the ice until the vehicle comes to a halt. Fog can affect the braking distance purely because that reaction time is then affected. The roads can be a bit slippy. Braking distance again will be longer. Tyre quality. If you have got bald tyres or reduced grip on your tyres, again the friction between the road and the tyre is reduced. There's less grab on the tyres as such, so the braking distance will be increased because it takes longer for the motion of the object to cease. Mass of the vehicle also can have an impact. So trucks take a lot longer to stop than cars, okay, so especially trucks that are fully loaded. So if you are driving along, don't do an emergency stop or slam your brakes on in front of a large truck, because it will hit you up the backside because it's got more force moving it along, okay. So these are things that can affect braking distances. Okay, now, so we've looked at braking distance. and we've looked at this reaction distance. If you add those two together, so you've got that distance, say from the moment you saw the light turn red to you applying your foot to the brake, so you've got that reaction time. Add to that the braking distance, and that's how we work out the stopping distance. So how far, that distance that it's actually going to take before that object actually stops. So this is just an image showing the top vehicle. Straight away, brakes applied, there's no reaction time, or braking distance there, brakes applied. It took that object, that car, nice red one, in dry weather, 64.3 meters to stop. In wet weather, it took 90 meters to stop. So it's just showing the difference there between wet and dry, and then it's given a bit of a reaction time before it stops, and it's showing that increase in distance. We're actually going to look at this in learning intention number 3. Number 4. Okay, so in learning intention number 4, we're going to use a graphic chart to determine the overall stopping distances of a vehicle with various initial speeds. So if we think of our car, the faster the car's going, the longer the stopping distance is going to be. Okay, so why is that? So if you're driving at 40 kilometers an hour, so if we have a look up here, 40 kilometers an hour, you can see that we've got our reaction distance. Okay, so we're saying there we've got 17 meters of reaction distance at 40 kilometers an hour. So driving at 40 kilometers an hour, we've got 17 meters reaction distance, and then depending on the conditions, the orange is on a dry road. So have a look up here, we've got reaction distance, and the orange is dry road, that's braking distance, and this is braking distance on a wet road. So just at 40 kilometers an hour, our stopping distance, which is our reaction distance plus our braking distance, on a dry road would be about 26 meters, and on a wet road would be about 30 meters. Okay, we're going to up the speed a bit, and we're going to be in 60 kilometers an hour. Okay, in this case, our reaction meters is 25 meters plus, and on a dry road, we've got a 20 meter braking distance. We've got 45 meters between seeing the red light and actually stopping. Okay, whereas on a wet road, that increases to 54 meters. And then you'll see how that increases as we go down to 90 kilometers here, 90 kilometers on a wet road. See how, okay, your reaction distance is increased. Okay, and that's purely because the vehicle is moving faster. So your actual reaction time may be the same, but the distance taken, because that vehicle is moving faster, is longer, it's further. Okay, and then if you're on a wet road, you're going up to 103 meters in your stopping distance. We'll look at all these further in class. Remember to subscribe to my YouTube channel, ABCs of STEM. Thank you for watching. See you in the next video.